The BTR-80 stands as a landmark in the evolution of Soviet armored personnel carriers, APCs, representing a decisive step forward from earlier models in the BTR series. Originating from the BTR-60 of the 1960s, the BTR-80 was conceived to replace both the BTR-60 and BTR-70 while addressing the operational lessons learned from decades of deployment. Production began in 1986, and the vehicle quickly proved itself as a highly capable and adaptable asset in modern mechanized warfare. Its combination of mobility, versatility, and survivability made it a preferred choice not only for the Soviet Union but for numerous military forces worldwide. One of the most notable changes in the BTR-80 was the shift from the twin gasoline engines of the BTR-60 and BTR-70 to a single, more reliable V-shaped 8-cylinder CAMAZ 7403 diesel engine. Producing 260 horsepower at 2,600 RPM, this engine offered greater fuel efficiency, reduced maintenance requirements, and improved reliability in extreme conditions. The installation of this powerplant required a redesign of the rear engine compartment, resulting in a raised hull line at the back of the vehicle. Despite these structural changes, the BTR-80 retained the signature 8-wheel layout of its predecessors, maintaining both the mobility and redundancy that had become a hallmark of Soviet APC design. The 8-wheeled configuration, combined with independent suspension on all wheels, allowed the BTR-80 to traverse challenging terrains while retaining high-speed performance on roads. Steering was applied to the front four wheels, and the inclusion of a centralized tire pressure system allowed the driver to adjust the tires for varied surfaces without halting. These features ensured that the vehicle remained agile across mud, sand, and snow, enhancing operational flexibility. Armament was another area of significant improvement. The BTR-80 featured a low-profile, one-person turret capable of full 360-degree rotation and 60-degree elevation, allowing it to engage targets at varying angles, including low-flying aircraft. Its primary weapon, a 14.5 mm KPVT heavy machine gun, was complemented by a 7.62 mm PKT general-purpose machine gun, providing both anti-personnel and light anti-armor capability. Modernized sighting systems, including night vision for both the driver and commander, along with an infrared searchlight, enhanced operational effectiveness in low-visibility conditions. These upgrades allowed the BTR-80 to provide reliable fire support while retaining a relatively compact and mobile profile. Crew and troop capacity were also carefully considered in the BTR-80's design. The vehicle typically operated with a three-person crew consisting of a driver, commander, and gunner, while the rear compartment could transport up to 8 fully equipped infantry soldiers. The layout allowed passengers to actively participate in combat via rounded firing ports on the sides and front of the hull, each fitted with ball mounts. Troop ingress and egress were facilitated by horizontally split doors on the hull sides, positioned between the wheel axles, as well as a roof hatch for rapid entry and extraction. The lower portion of the side doors doubled as steps, while the upper portion opened forward, providing ease of access under combat conditions. Weighing approximately 15 tons and measuring 7.65 meters in length, 2.9 meters in width, and 2.35 meters in height, the BTR-80 was designed with operational range and endurance in mind. It could cover up to 600 kilometers on a full fuel load and reached top speeds of 80 kilometers per hour on smooth surfaces, with slightly reduced performance over rough terrain. Its 8-wheel drive and independent suspension provided a level of mobility that rivaled tracked vehicles, while offering superior speed and fuel efficiency for extended operations. The vehicle's design also incorporated a degree of survivability. Even with 2 damaged wheels, the BTR-80 could continue moving, allowing crews to withdraw from dangerous situations without immediate external support. Amphibious capability was another key feature. The BTR-80 could navigate calm rivers and lakes at approximately 9 km per hour using an integrated water jet system that required no additional preparation by the crew. This capacity enabled rapid river crossings and flexible maneuvering in regions with diverse waterways, adding a significant operational advantage in both offensive and defensive operations. For protection against non-conventional threats, the BTR-80 was equipped with a nuclear, biological, and chemical, NBC, defense suite, featuring a pressurized fighting compartment to protect the crew in contaminated environments. 6 smoke grenade launchers mounted on the rear of the turret provided additional concealment and defensive options during combat. While the vehicle's armor could stop small arms fire and artillery fragments, it was not intended to resist larger caliber anti-tank weapons, making speed, maneuverability, and tactical positioning essential elements of its survivability strategy. The BTR-80's performance in the field quickly proved its value. Its off-road capabilities were nearly on par with tracked vehicles, while on-road speed and endurance offered a distinct operational advantage. The combination of mobility, firepower, and troop-carrying capacity made it a favorite among Soviet units, and its design versatility allowed it to be adapted for multiple battlefield roles. In addition to serving as a standard infantry carrier, the BTR-80 chassis has been modified to accommodate command vehicles, ambulances, signals vehicles, and mobile communication stations, demonstrating the platform's inherent flexibility. Internationally, the BTR-80 found widespread adoption. Countries including Ukraine, Romania, Hungary, North Korea, South Korea, and Colombia acquired the vehicle, often developing localized variants to meet specific operational requirements. Ukrainian forces, for example, have expanded the BTR-80 family into upgraded models with enhanced mobility, protection, and electronics, reflecting the vehicle's adaptability to modern warfare. The platform's ability to integrate various weapon systems, including heavier cannons and machine guns, further underscores its utility across diverse combat scenarios. In 1993, the BTR-80 underwent another significant upgrade with the introduction of the YMZ-238M2 engine, improving performance and reliability. This enhancement reinforced the platform's relevance in modern mechanized forces, allowing it to maintain competitiveness despite evolving threats. Over the years, more than 5,000 BTR-80 units have been produced and deployed in at least 35 countries, solidifying its reputation as one of the most successful wheeled APC designs of its era. The BTR-80's legacy lies not only in its technological improvements over previous models but also in its ability to balance mobility, firepower, and troop protection in a single, versatile package. Its influence can be seen in the continued evolution of wheeled APCs around the world, particularly in designs that emphasize operational flexibility and adaptability. While it may not possess the heavy armor of a tank or the firepower of dedicated assault vehicles, the BTR-80's unique combination of features ensures that it remains a capable and respected asset on battlefields where speed, maneuverability, and versatility are critical. In conclusion, the BTR-80 exemplifies a design philosophy that prioritizes practical battlefield effectiveness, combining lessons from earlier Soviet APCs with innovations that addressed the needs of modern mechanized warfare. Its continued service and global adoption demonstrate the enduring relevance of wheeled armored platforms capable of fulfilling multiple combat roles. Whether transporting infantry, providing fire support, or performing specialized missions, the BTR-80 remains a benchmark for wheeled APCs and a testament to the enduring effectiveness of adaptable military engineering.